This example contains a little bit more complicated database because it has converters in it. The rest of the database is quite straightforward. So let's open this and see. A product list. I already cloned this at the previous lesson, so I assume that you have the clone of it. And I do have the clone of it, so I will open clone. Close project, product list. Do not update it for now, because it can break it. I mean libraries. So what is specifically interesting about the database? So let's open it. This is data access layer. It is local database. I have local product, which is entity for the table products. I have primary key, also integer, auto-generate true. I store string, double, int, boolean, condition. What is condition? Condition is enumeration type that I define it. Obviously, if I define type, I need to provide converter because database cannot imagine what I could define, right? So if we define type ourselves and we use it inside of entity, we do need to provide converter. It's one of the cases when it is absolutely necessary because database cannot figure out how to convert it. Or how, if it can figure out it's not necessary, we'll do it the way we want. So it's one of the places. And also date. We need to provide conversion also for the date. Why? Because SQL date is not the same as Java date. It's not, there's no match. So we have to provide information how to store it. So there are two kinds of conversions here. And also, you see, I provided column info. So by default, column will be called date. But since I provided column info name timestamp, this will be column called timestamp in the database. All right? So this is entity. Next, let's define DAO. In the DAO, product DAO, I have select all from products, order by name, will be creating flow of list of local products. Okay. Because it is select all, it means entire row, and entire row is mapped to local product. So flow will be list of local products. In the previous example, I selected only one column, so it flow would contain the data from that column, not entire row. What is this? Select all from products where ID is equal to. Select by ID in the previous example was suspend function because I asked it for data. But when it is flow, it's not suspend because flow provided empty first. You don't need to wait for empty object. Okay. And it is flow of product or null. Why it is null? Because ID doesn't have to exist in the database. So it will give null if it's empty, if there's no such ID. Okay? So what is this one? Insert. If you try to insert object with the same ID, it will create a conflict. So I provide information if there is conflict of ID, conflict on ID will just replace, ignore will just replace it. This is example of update. As you see, there's no need to create query for update if you provide parameter just entity that is matched to the row. It will just replace content of the row with new data from this object. Another query. Update product quantity by ID. So I provide ID and new quantity of that product. Okay. So I need to do update product set quantity, this quantity where ID is equal to this ID. So this is a little fancy query. Okay. So update quantity by ID. So when it is used? Okay, starting. So in this program, there is a button called cell that will reduce quantity by 1. So now we have a quantity 23. It is 22 now, you see? 21. And this is how it is done. I'm calling function updates quantity by ID. What is this? There is a data field in the object called selected, which is Boolean. It is used here to make this selectable, you see? So it is done by this update function. I provide ID, I provide selected, not selected, and it is updating this stuff. Okay. Next, delete product, and as I previously mentioned, if you provide entire object, you don't need to create query. If you need to have query, yes? Yeah.
So just the function definitions. Then the query statement above that, so when you call the function after this query.
Implementation of this interface is created by the system automatically when we create database. Remember database builder function. That is generating the stuff. So database builder creates implementation of this DAO. We don't write code for it. We just write query, because without query, it's have no idea what you need, right? And this part, delete product by ID, does require query because it's ID, right? And this is, you provide entire object. So this is creating. This is DAO. Where is my database? Product database. Where is that stuff? I remember we had part of this code specifically designed to make singleton. Remember, I spent stuff explaining it. Unfortunately, it's not really avoidable because if you do need to convert objects, convert older database into newer one, when you remember update your released product, so users do not lose data. You still have to create that older way because you call database builder right away from this. Oh no, sorry, I'm wrong. My mistake. Okay, my mistake. The part that guarantees that it is singleton is not here because Hilt will guarantee that it is singleton when you write singleton on top of it. Okay. So remember the part that is creating object using builder here. It was part that creating this object. And now it is in different place. Where it is? It is in data module, this one. Room, database builder, context, product database, you see? And if you need to convert your data, you will add extra lines here. So you don't need to create that singleton implementation inside of that object anymore because you write singleton on top. Hilt will guarantee that it's singleton. So Hilt makes it slightly simpler. You don't need to create that object. You don't need to create that get database method inside of database class. We synchronize it this, remember that code, right? Why? Because Hilt can take care of it. This program does not have a version without Hilt. This is why I didn't have to worry about this piece. Previous one has 2 versions, so since I had to have the code, so I decided to keep it even in Hilt version. Okay. So data module also creating objects in the same sequence, and product DAO can be function. In the previous example, I created product DAO is a property, but you can create function. Both ways are just fine. So in product database here, product DAO is function. In the previous example, it is just value. System is smart enough to create function instead of it, instead of just value. It's not important, actually. It's just whatever. Either function returning DAO or just data field containing DAO that will be assigned. Okay. So converters. I didn't mention converters. So how to deal with converters? Converters are mentioned here. You see? This is abstract class product database, and this is class providing converters. It doesn't have to be called converters, but whatever class is inside of type converters. I look it up, it has to be inside of just one class. So what is inside? You provide converters class doesn't have to be annotated with anything, but methods that do type conversions needs to have type converter on top of it. So what kind of conversions we need? Remember that my condition, it was enumeration type. Let's find it. It is in domain condition. New like new, very good, good, acceptable. It is condition of the product. So if I click on this and click edit, you will see this. Okay? This is condition of the product. Since I made up those words, I can store it as a string and do conversion to enum, or I can store it as integers. It is actually easier to store this to integers. So this part is stored as integers. So let's see how it is converted to integers. So we use it this, right? So I need to convert enum to integer. So whatever you provide object type enum, dot ordinal will convert it to integer by counting this. First index is 0, second is 1, and so on. Okay. So conversion to integer is easy, right? Then conversion from integer to enum. Conditions this enum. If you call dot entries, it will be array of objects in the enum. You use ordinal for it, and it will create enum. So this is how to convert between integers and enum. You use entries and ordinal. Ordinal will give index, entries is an array based on that index. Next, remember, I also needed to convert to date. Why? Because date in Java, this is Java date, use it in Kotlin. It's not the same as date in SQL. So I decided to store it as long integer. Why? Because it's easy to convert. So if value is long integer, date corresponding to that long integer will be constructor call for that value. Why it can be called stored as integer? Because there is some zero time for the date at some time in 60s, I believe. Do you remember when is zero date for computer? Okay. I forgot. Sometime, a while ago, is considered zero. It is for computer purpose. This is why we can convert dates to long integer, and it is in milliseconds since that time. And if I have a date, date.time is that long integer. So date object is storing date actually as long integer inside. And when you print, it is just converting long integer into string. So this is how to do conversions. And of course, you can store it as a string and convert it from the string backwards. It's another choice. So we're about to finish because time, okay? And I think I explained everything related to the database. Obviously, this program is a little fancier than other programs, not because it has a lot of GUI, it has some specifics about GUI. I will use this program to explain how to use views inside of compose. What you see on the screen is a view, this part. No, this is compose, but rating bar is a view. So this program is also demonstrating how to use older GUI inside of new GUI. This rating bar on the screen, it's part of the old GUI, inserted into new GUI. Just because not everything in the from the old GUI is converted to new GUI, it's also useful skill. How to insert older GUI into a new one. There is no rating bar in Compose so far. They didn't make it. They did create drop-down list, so it's not an issue. But this drop-down list, it's called spinner. It's a part of older GUI. So it's also, this is also showing how to insert this from older GUI. How to do drop-down list in new GUI? You saw this example in dice roller. In dice roller, we had drop-down list. Questions? So, time. Exact time. So next time, see you on midterm. Right. Midterm is on Tuesday. We will not have lesson on Friday. Sorry. Unless you really want to. I will use this time to write new examples because I edit Firebase. I need to go through existing examples, clean it up, remove things that are not necessary to make it simpler explanations. Okay. I will use it for productive, not just relaxing. Okay. And it definitely requires more than 3 hours. Which program can be done in 3 hours? Only very short ones. Yeah. Questions? No? So, yes?
So for the exam, it's 2-part, right?
Yes.
The first part is just quizzes, like MCQ and
just like you had quiz for take-home one, but it will be in class only one attempt.
And then no short answer or anything?
No, only true, false, and MCQ questions from the same pool. So some questions may overlap. You just exactly the same. But it's not guaranteed that all of them will be the same. It's about like half.
And then for the second part is the pet data.
Pet data, simplest version, but it is not about pets. Could be about books, could be about clothes, whatever. Mhm. Yes?
Will there be any like collapsible thing for the pet data or the?
No, it's just pet data as it is,
Just
without collapsible things. In the tutorial, it was like for simple animation to close it. No. Also, pet data simplest version because there are three. You saw pet data with hilt injection and also pet data with navigation. When you click on item, it shows details. No. Just simplest one. Okay. Without navigation, without dependency injection, without repository, just display list from hard-coded list. But use view model. Put it into view model and display from view model. Like pet data, simplest.